Alright guys, so P1 day 3, we're going to be looking at solving inequalities. Okay, so we have done this before, but we're going to introduce a new notation called interval notation. So, graphing inequalities. We use an open dot for greater than or less than, and then we use a closed dot for greater than or equal to, or less than or equal to. Okay, so if you remember our inequalities, and this is for when we're graphing them, right? So an open circle would look like this, a closed circle would look like this. So the new thing that we're talking about is interval notation. Interval notation is a way to write the solution in an inequality using infinity symbols, parentheses, and brackets. Parentheses indicate not included or open. Okay, so this statement is important. So what that means is if there's a parenthesis next to a number in an inequality, so an inequality is written like this, some kind of number, comma, some kind of number. And if there's a parenthesis here, it means that it's not included. So that number would not be included in the solution. Okay, brackets are another important thing, and this indicates included or closed. So then we would say bracket with a number, comma, a number, and then a bracket, and that means we would include the number in our solution. Okay, so then let's take a look at this. It says directions. Graph each inequality and then write the solution in interval notation. So number 1 says we want all of the x's that are greater than or equal to 8. So then on this number line, okay, it doesn't need to look beautiful. Because there's only one number we're dealing with, we're just dealing with 8. I'm okay if we just use 8. The greater than or equal to sign tells us that at 8 there is a closed circle. And then if we want everything bigger than 8, what we're drawing is all of this stuff to the right of 8, right? Because these are all the numbers that are bigger. We have 9, 10, 11, etc. So how do we write this in interval notation? Well, because we closed the circle, that means 8 is included in our solutions. So then we have a closed bracket. Okay, so that's 8. And then it looks like we're going to the right forever. So how long is forever? Well, in mathematical terms, that means it's going to infinity. And with infinity or negative infinity, we always use a parenthesis. Okay, so at this point, you could pause this and then do number 2. Okay, but I'm going to keep going so that we can just keep filling out the notes. When you turn these in, I want all of the notes to be completed though. Okay, so whether you want to do them while we're doing this and just pause it, or if you want to just do all the rest that we didn't do at the end, that choice is up to you. But all of the notes do have to be filled out. So, continuing on, solving inequalities. These follow the same rules to solve an inequality as you do an equation. There's only one difference. You have to flip the inequality symbol if you multiply or divide by a negative number. Okay, so that's one difference that happens when we are solving inequalities. Hey guys, sorry for the super awkward cut. I had to fix number 3. I made a very silly mistake. So working through number 3, I'm going to work it so that we have to divide by a negative and flip our inequality. So if we subtracted 7v from both sides, that gives us negative 2v plus 1 is greater than negative 17. We subtract 1 from both sides, we get negative 2v is greater than negative 18. We divide by negative 2 on both sides. As soon as we divide by that negative, inequality sign flips, and we get v is less than 9. So then we throw a 9 on our number line, an open circle, and then we draw a line to the left of that open circle because we want all of the values that are less than 9. When we write this in interval notation, it's going to be a parenthesis, negative infinity, because we're coming from negative infinity if we go this way, and then we're stopping at the number 9. So then it would be negative infinity, comma 9, and both of these things have parentheses because remember, infinity always has parentheses, and because it's an open circle, we also put a parenthesis. All right, moving on. Let's take a look, and let's talk about some compound inequalities. So the first type of compound inequality is our OR statement, okay? So OR statements always go away from each other because ORs go opposite directions. So how this would be written is we're going x is, actually no, -4, right? Because -4 is this number. -4 is less than or equal to x, or x is then greater than 1. Okay, we know that this is a 1 right here because after 0 comes 1, and it's an open circle, so that means it's just a greater than symbol. If we were to write this in interval notation, we would say -4, whoops, not -4. We have to start at the end of this, right? So if it's an arrow to the left, it's at -infinity. And then that goes up to, right, where do we stop? We stop at -4. And then it's closed, so we're going to use a bracket. The OR symbol when writing interval notation is this U without a little tail. And then the next spot that it starts is at 1, but it's not equal to 1, so it's open because it's an open circle. And then we say 1 to infinity. Okay, so this is the same thing. One's in interval notation, one's in inequality notation. The biggest thing is we want to start learning how to get familiar with this kind of interval notation, because eventually we're going to start writing the domains to graphs and using interval notation a lot. Okay, so to solve OR inequalities, you solve each part, then graph on a number line to show the solutions. So ORs, we just solve like we would always solve anything, right? We just have to do it twice. So we have to solve the left side, and we have to solve the right side. So solving the left side, we subtract 4 from both sides, 3x less than or equal to 6, divide by 3, and we get x is less than or equal to 2. On the right side, we're getting divided by 5, and then we're going to say x is greater than 9. So then x is less than or equal to +2. So we go +2, close circle, and then we're going less than that. So we're going to the left. And then we're going 9, which is not even on here. So 9, open circle, and then we're going to the right. Okay, and then if we had to write this in interval notation, we're talking about -infinity all the way up to 2, and then we close it. And then union, that's called our union symbol, the U is. And then we open circle at 9, and then we go to +infinity. Okay, so that is how you would solve OR inequalities. Okay, type number 2 of compound inequality is our AND inequality. So if we're looking at ANDs, it means they're compound. They're compounded together, okay? But this time you can see that we're actually just going over a specific interval of numbers, right? We don't go to infinity. So that means when we start writing this, we can have -2 at one end, because that's the lowest number. And then we would say -2 is less than or equal to x. And then we would say that is less than 5. Okay, so this means x is between -2 and +5. And that is all of this shaded in region. Okay? The interval notation for this is similar, right? So because -2 is the closed portion of this, we would use a bracket, and we would say -2. And then because it goes to 5, we would just put a comma, and we would put a 5. But then because it's open at the 5, we would put a parenthesis. So this is telling us the solution includes all of the values from -2 up to 5, but not including 5. Okay? Because the solutions to an AND inequality fall between two endpoints, they are frequently written in a more condensed form. Oh, we already did that, sorry. This is the more condensed form of an AND inequality, right? It was talking about doing something like this. So x is less than or equal to, so -2 is less than or equal to x, and x is less than 5. Okay, that was the uncondensed, and then we condensed it. -2 less than or equal to x, which is less than 5. Whoops, got ahead of myself a little bit there. Sorry about that. Okay, solving and inequalities. If the and inequality is written out, solve each part separately. If condensed, you can solve it all together, working inside out. Then graph to show all possible solutions, okay? So you're not usually going to see something like with the and, okay? It's usually going to be condensed like these three. So actually, I'm okay if we just skip number 7 and just drive right into number 8. So for number 8, we start in this middle section here because we need to get that variable by itself. So to get a by itself, we're just going to add 1 to every single side of this. Now there's 3 sides, one side here, one side here, and one side here. So we have to make sure we add 1 to each side. That's going to give us -1 is less than or equal to a, which is then less than or equal to 7. So how do we put that on a number line? Well, -1 is the smallest one, so we start here. Then we're going to go up to 7, so we go to here, and then we just connect those 2 dots. Bada bing, bada boom, right? And then interval notation, bracket because it's closed, so -1, all the way up to +7, and then we bracket it again, so closed. All right, I don't want to go any longer in the notes here. I think you guys hopefully have a great idea and can finish 9 and 10 on your own. Okay? If you have any questions, please bring them to class. I'm always ready to answer them.